So I have to admit, I'm a smart home nerd. And this whole Internet of Things thing is really exciting and interesting. And just to see how much data you can collect from your own home, of course, controlling it is fun. Being able to dim the lights and do whatever is really fun, but collecting all kinds of metric from your house is a really interesting proof of concept on how you can gather intelligence and use the data streams that Internet of Things provides to get new insights. This talk is not about that, but I thought I'd show you really quickly. Let's see. So these are all the data points my house is currently collecting. It's quite a bit. Most of the lights and switches and sensors, motion sensors. Netatmo is collecting noise and so on. And this opens up just a bunch of automation possibilities, scripts and being able to detect what's going on. And basically, I'm just scratching the surface. But at the same time, my next project would probably be about machine learning and how to plug this into some, what kind of intelligence about the behaviors in my family can you build from this? So this talk is about how I built an automatic power meter reader in my house. But I'd like to start, and the first third will be about why I built a power reader meter for my house. 5 years ago, I was so fortunate that I was allowed to become the CTO of a fairly decent software company called Fronter. It used to be one of the largest providers of learning software in Northern Europe, with 8 million users globally. And it was really exciting to get started. It was just that there was this one immense problem. There was this enormous technical debt in the solution. And the whole company was, or the development department, was really disillusioned about what they were allowed to do with the solution, how they could fix the broken monolith that they had. And I spent a ton of time to convince people that a new kind of architecture was needed. When you become a director, a CTO, two things happen. And the first thing is that your hands-on knowledge about what's going on with technology is starting to rot. You don't realize it right away, but after just a couple of months maybe, but at least a couple of years, you start to get out of touch with having a realistic vision of what is realistic for your teams. The second thing that happens is that the best way to be a good leader for really knowledgeful experts in their field is to just let them do their thing. Normally, you'll listen to the expert or the advocates and the visionaries, the enthusiasts in the group, and maybe guide them a little, but you say, yeah, that's an awesome idea. Go ahead with Linux containers. Of course, yes, sure. Go ahead, let's do that. Let's break it up into microservices. But as a CTO, what do you do when that enthusiasm is not in the organization? How do you build that kind of enthusiasm? And the first thing, if you want to convince people who are experts in their field that this is an approach that is worth attacking, you need to, the best way is to convince them by example. So one of the big reasons I built this was to get up to speed with container technology, which I just read about. It was exciting. People had talked about immutable infrastructure, building the virtual machine together with the rest of the system as part of the continuous integration loop to build much more robust and fault-tolerant systems. And then Linux containers with Docker ahead of the field started to emerge and was really exciting. And I really thought that we should start building a new modular architecture based on this technology to create much more robust and modular tools and application, and as a strategy to get away from the big ball of mud monolith that we'd had before. So I did this talk. This is an illustration from a talk I did internally to convince people internally that we should really go this direction. And I was talking about the trends, right? So in 2004, if you had a really well-designed web application or application, you had a clean MVC 3-layer architecture, right? You had the views and you had the controllers and you had your model, and that was fairly easy to maintain. And then through the 2000s, right, people started to separate the views from the controllers and models more and more cleanly. You had ORM interfaces, proper object separation, better and better APIs, and in the web service fields, JSON and REST started to emerge as the dominant standard. So in 2012, people were talking about Web 2.0, mashup of websites. Google had started to provide really good APIs to their Maps service, to different kinds of service. And the big providers like Facebook started to have a really good OpenAI, and you can see this emerging. And already there, it was really clear that more and more applications were built as completely decoupled services where you talk to the entire internet to build really awesome views with much less complexity in the front end. And it didn't matter anymore where you hosted stuff, because Amazon had launched their cloud, the EC2 cloud. You could really see where things were going. I was starting to convince that this is where we need to be headed to be competitive in the future. And I also tried to visualize where we're at currently. So this is the illustration I created to try to visualize the state of the frontier system at that time. A complete mess. It was very understandable that it was that way, because it had been built for years. It had been layer of fixes without ever stopping up and really refactoring or rebuilding the system. Actually, one of the first things people told me that the previous year with the previous CTO, there's been these posters on the walls, no refactoring, only new features, stop whining. So management of the company has forbidden any kind of refactoring, because all focus should be on just adding new features. So part of my struggle was how to mitigate this and how to counter this and reverse some of these decisions and convince that the only way forward to build a scalable, maintainable, viable system was to reinvent the architecture and start building much more separate and modular tools for the future. So together with the technical leader group, we did the reorganization of the development department. This talk is not about that, but together with the new architecture group, we built, this is the first sketch of the new principal architecture. We started out with a new modular tool called the planning tool. We created a new planning tool for teachers. And it was to be built completely separate from the rest of the system, from the legacy. So basically, we did a review. We talked about what kind of technologies do people find exciting, because that is also really important. It's not about what you already know, but it's also about what kind of tools your development engineering department finds exciting, that they are enthusiastic to go that extra mile to be allowed to work with. So we ended up choosing Node.js over PHP, Python or Java, which were the competition internally. So we chose Node.js as the backend layer. This was pre-React. So we reviewed different JavaScript front-end frameworks, and we ended up using Angular. And then we said that we'll have a completely separate API backend, only talk through APIs from the front end, and then we have a native iOS and Android front end talking through the APIs. The same APIs will be used by the Angular web front end, and then we can experiment and build and also use Cordova or WebView front ends to continuously experiment and see what is the quickest and cheapest path forward. And then we established that this tool will only be one in a portfolio of new tools. So we reversed the hosting paradigm, if you like. Previously, you'd have the domain, and then you'd have a slash-like and a folder, and tools would be hosted in subfolders within the old monolith. Instead, we reversed it, so you'd have the service name, planner, the host name, so that it could be hosted as completely separate services. They could be completely decoupled from each other and hosted in completely separate places in the clouds without any kinds of proxying or forwarding or reverse proxying through Nginx and doing that kind of stuff, which really let the teams develop the tools independently. So we tried to completely isolate the legacy, build up a new portfolio, and I needed to prove to the company that this was a viable path forward. And I wanted to do it in a way that I was motivated to spend 5 or 6 hours at night finding it fun instead of doing other stuff in my spare time. And I needed in a way that let me be motivated about showing a proof of concept of how to actually build a scalable, maintainable, microservice-based architecture. I'll skip this one, I just like the illustration. So, back to the core of the talk, how I built the power meter reader. So, this is my power meter, and annoyingly enough, it is one of the new automated readers. When I started this project, it was a manual reader, all rotary dial, just dialing, and last year they upgraded it to this one. And I was afraid that all my efforts to actually read it automatically would be in vain, and that they'd had really cool new APIs I could use. But no, they don't have the APIs. I'm still dependent on the old solution, right? Because it sends the meter data to the electricity company, but I don't have an API to read them back. I can't integrate this with my smart home. So this power meter has a blinking LED. So it blinks 1,000 times per kilowatt hours. And so if there only was a way that I could count the number of imps per second, of course there are. Enter the photoresistor. So how many of you guys have done microelectronics? Yeah, so this is basically a really simple circuit. The light blinks every time a circuit closes, and you get electricity flowing through the circuit. And a photoresistor or photoconductor, it starts to conduct electricity when the light rises above a certain threshold. So whenever the LED blinks, electricity flows through the resistor for the time it blinks. And it's a real simple circuit. You add some resistors for some couple of thousand kilo ohms, and to reduce the current flowing through the resistor, and then you just is there a current flowing or not, and that's basically an imp. So this is how it looks. This is the photoresistors just gaffer taped over the LED. Some cheap wires I found. Actually, the wire is from some IKEA LED lights, and they fit perfectly to the connectors on the photoresistors. I just used that. And this flows to the Raspberry Pi. So there's the Raspberry Pi. There's a LED connected there to the breadboard for just to verify that everything is working. It's like really good to have like some kind of visual quality assurance there, because I can still see the LED blinking behind the gaffer tape when it's dark there, and I can just see that the blinks or imps are synchronized, and I get a gut feeling that it's actually working. And let's see, is there, I don't know how to turn on the laser pointer here. Is it this one? Yes. No. Okay. So it's a really simple circuit. I take out the 5-point voltage up there from the Raspberry Pi, pipe it into the plus here. I then have a connector from the plus into the breadboard. There's a resistor there reducing the current, and then it goes up through the other side, and that goes into the pin number 18, which is then read back into the Raspberry Pi. And I measure how long each imp are, and I measure how many blinks there are per second, and then I get the kilowatt-hour average. Or actually, I can very easily calculate just both current wattage and kilowatt-hour consumption over time. So this is the current architecture of how it's built. I just plug the data stream with ones and zeros into an input port on the Raspberry Pi. I use the Node.js library on-off, which is a really good Node.js library for the Raspberry Pi to count it, and then I just pipe the data. This connector should go out of the Raspberry, or so the Redis library, but because of prettiness reasons, I drew it there instead. But the data stream is just piped into a Redis server, which is a NoSQL server. In the first implementation, I did the different data transformations I wanted to do inside the core library here. Did a lot of logic, because I want to create statistics and separate data lists for daily consumption, weekly consumption, monthly consumption, those kind of stuff. But I wanted to refactor that out so that this was as simple and robust and fault tolerant as humanly possible. The only thing I wanted this module to be responsible for was to read the data from the Raspberry Pi and pipe the data straight into the Redis server. And then I have a timer loop. I actually wrote a separate NPM module for this called, let's see if it's not the next slide. To emulate crontab for the Raspberry Pi. I also wanted to implement the pub/sub pattern, or quite similar to the observer pattern, but the event-driven pattern. Instead of going into like this procedural, promise-based JavaScript architecture, I wanted to base everything as much as possible on just event streams and as close to functional programming as I could, with all state as input to each function. And either it was done or it emitted a new event telling the rest of the system that it was done, and others could pick up the event and pick up the data from there. So each function reacts to events and then emits events if they have something to notify other parts of the system about. So then there's a PowerMeter API web app implemented using Express to just read the data from the Redis servers and expose a real simple web service API going out on the other end. And just to simplify maintaining this, I decided on using the Kong gateway. How many here know about Kong as an API gateway system? Excellent. We use it in Oslo municipality. We use it in ObjectNet in Oslo for quite a few projects. And it is really an efficient, really cool, open source, but now they are bootstrapping a company for it. Really good API gateway. It lets us refactor out everything that has to do with authentication. So you get authentication, API monitoring, logging, access control list, rate limiting, so on and so forth out of the box. You don't have to implement that. And if you want to build a really scalable microservice architecture, that is something you really want. I see a lot of guys presenting microservice architecture, just drawing a bunch of small boxes with lines chaotically going between the different modules. That is not how you build a microservice-based system and make it scale. Having control of the complexity and interconnections between your modules is key to have a maintainable, scalable system. Also, you want to factor out as much complexity from each module as you possibly can. You should host them in its own private network, so you don't have to worry about HTTPS between the different microservices if you don't want to. You want to you really want to put something like Nginx in front of it for SSL termination. And in this architecture, of course, I put Cloudflare as well in front, which gives me reverse proxying and CDN and IP masking out of the box. And also because they have a really awesome free tier, they let me do a lot of stuff for free. Caching the data and building everything. So that's the rationale behind Kong, and just having either API key authentication, JSON Web Token authentication, or OAuth2 authentication out of the box. It is really awesome, and it really simplifies each microservice and make you build out and scale your system real efficiently. So this is a short example of the API in practice. So basically, I just wanted really simple JSON endpoints to query about all I was interested in. So basically, I have one API to just, let's see, that's the second one, that just returns the current consumption in watts. The default is it takes a 10-second average and tells me the wattage or the number of watts I've used for those 10 seconds. I can give it a parameter so that it can be 1 second, it can be 30 seconds, it can be a minute. And then I can get the kilowatt hour consumption for a month, a week, a day, an hour, and so on and so forth. This is the NPM module I wrote for the project. Basically, whenever I concatenate or collect the data into the weekly list or monthly list or yearly list, I have a crontab syntax that let me just define the different time periods an event should be emitted. And every 10 minutes or 10 seconds or every day or every week, an event is fired, and the function responsible for collecting or aggregating that data and enter a new data point into the list is fired. So the big benefit of this, it makes it really, really simple to build different interfaces and different views to the system. So this was a proof of concept I did to see if Cordova and Ionic, which is a mobile-based Angular framework, would scale to actually be used in professional-looking applications. Would the user interface and with the look and feel be good enough? So just having this test API made it really, really simple to build different APIs and views, and also experiment with getting authentication with Google Plus and Facebook going in. And the reason why I did this is it's not only because I'm fun and think my family is boring, but it's also because I wanted to win by proven example, resistance in the engineering department or leadership in the company I was working in. because I got resistance like, oh no, we can't refactor this and start using Docker containers. It's too much effort. It's not possible to transform from the old system to the new one. No, we haven't interfaced with Facebook before. It might be difficult. And I was convinced it was simple. So I wanted to prove by example that it's actually quite simple to do. And also by example that it's quite simple to do securely if you just do it wisely and integrate at the proper places. And it is. When the companies or services you want to interface with have clean and simple APIs, building user interfaces and building applications on top is surprisingly simple. But of course, you need to be able to deconstruct your application and focus on building those really simple, clear-cut interfaces between the modules. Because if you miss at that, you'll just build new complexity. Building clean APIs is key to keeping the complexity of your solution as low as possible. So this is another view I built. This is just a Google spreadsheet that there's this open source script plugin you can just plug into your Google Sheets, and then you can import JSON. You get a new function in Google Sheets, import JSON, and you just enter the URL with parameters. So I just entered the URL with an API key, and I can graph data in a Google Sheet directly from the API and directly from my Power Meter. It would have been impossible to do if I hadn't built that API. This is the new view. This is the API plugged into my smart home solution. Home Assistant is an open source smart home solution implemented by a bunch of people from around the world. And it integrates awesomely with all kinds of stuff. Out of the box, I get both Alexa and Siri or HomeKit integration. It's the only system I've used that lets me plug in IKEA Trådfri, Hue, Z-Wave, other smart home solutions, and it just works together out of the box. And you can create collected groups and scenes based on all different kinds of systems from different providers at home. And here you see the current consumption just plugged directly into smart home. This is a screenshot, but yesterday when I made it, it's a live graph of the current consumption. Actually, the variance in the 7-day consumption over a day, and the average of the weekly consumption. So if you want to know more about the details of the code or review it and look at it, all of it is hosted on GitHub. Just grab me or reach out to me on Slack or whatever, and I'll send you the URLs. You can even find it if you search. And that's my presentation. Yeah, we have 1 hour and 38 seconds if there's questions. All right, I'll be here, so just grab me if you want to know something. Thank you.